The Earth. I know it has been referenced countless times in the past, but this is our home planet. The place where we have lived all of our lives. The place where we made all of our memories. Where we've met everyone we know. In this planet there's life, gargantuan oceans, and in some places it is teeming with life. Above all this, there's us, humans, the most intelligent beings on our own planet. We always want more, even though we have plenty of things to stay happy. We always want more knowledge. That particular characteristic made us what we are today. That made us consider ourselves as intelligent. Curiosity made us also think about something else, other intelligent beings. If you think it's nearly impossible for us to be alone in this universe, it's just so big. It's so big that we can't even visualize it in our tiny minds. Curiosity made us think. Are there any more intelligent species in this universe? You might think that to find alien life you would need to go very far, maybe a few million light years away, but there's a catch. Alien life does not need to be intelligent. Yeah, I know that sounds kinda stupid, but that's the definition astronomers use. It can literally be just some bacteria, that's it. Those were the inhabitants of Earth about 3 billion years ago. But still, how would we find those forms of life on our surroundings? Easy! From the start there are two main candidates, Europa and Enceladus, Jupiter and Saturn's moons respectively. They are thought to have a subsurface ocean which could possibly house life. This small video from the European Space Agency demonstrates how there could be a subsurface ocean on the Galilean moons orbiting Jupiter. As we've seen in the previous demonstration, Io is thought to have a subsurface ocean made out of magma or hot metals. Scientists think that there may be life on those Jovian moons because there's indeed a salty ocean. If it were just an ocean with water, life could have not developed, but because it's salty water and we know from the experience here on Earth that life develops with salt, and salty oceans might be another potential for life. There are still many questions left to answer with these predictions, but we'll explain them later. For example, how do the moons get heated? How do we know that there are indeed subsurface oceans on Europa and Enceladus? But this video will mainly focus on one of Jupiter's moons, Europa. That doesn't discard the fact that Enceladus, Callisto and Ganymede have subsurface oceans. It is just that it will be easier to explain planetary oceanography with this one example. I've chosen Europa for a simple reason. It is both magnificent and mysterious. Who knows what's hiding under the crust of the Jovian moon? There was also another factor that influenced my choice, the fact of the mission Europa Clipper, a mission that was designed to explore Europa in the next few years. It was launched the 14th October this year, and it is planned to reach Jupiter's orbit in 2030. But first, let's get to know Europa a bit better. Europa is one of the 4 Galilean moons, named after a very famous astronomer called Galileo Galilei. He was one of the first to make the use of the telescope, although a very rudimentary version of it. With it, he was able to discover these 4 moons: Io, Europa, Ganymede and Callisto. When Voyager 1 passed by Europa, it noticed something particular, something that is not seen anywhere else we've been to. There were no craters. Even though all the moons and planets are constantly being bombarded with meteorites, there were no signs of craters. That sparked our curiosity, mainly because we had never seen something like that. 16 years after the Voyager 1 flyby, Galileo was scheduled to enter Jupiter's orbit. For 8 years, the spacecraft studied both the gas giant and its moons. Galileo's readings suggested that not only Jupiter had a giant magnetic field, which we'll go into detail later, it had a rotating axis just like Earth. Here on Earth, our planet is tilted off its y-axis by about 23.5 degrees, while on Jupiter it's about 3.13 degrees. This makes the entire magnetic field wobble around with the planet, having a consequence relevant for our investigation. This wobbling induces a magnetic field on Europa, whose signals were once again captured by the Galileo spacecraft. This fact made scientists think that Europa needed an electrical conductive layer under its surface, now estimated to be around 10 kilometers deep. This electrical conductive layer reacts to Jupiter's magnetic field and creates one around Europa. Now, there's still one main question left to answer. How does Europa get heated? According to scientific studies, Europa's surface temperature is constantly about -160 degrees Celsius, making it nearly impossible for life to develop. But once again, physics comes to rescue us. The Sun is not the only way to get heated in the solar system. Another way comes with the help of Jupiter. As you may know, Io, Europa and Ganymede are in orbital resonance, on a 1:4 ratio, meaning that once Ganymede completes one orbit, Europa completes 2 and Io completes 4. This comes with another particular consequence. Because Europa is being pulled by Io on one of the sides, and is also being pulled by Ganymede on the other side, its 3.5-day orbit becomes eccentric. Due to that, Europa is constantly being squeezed in and out by Jupiter's gravitational field. It's scientifically proven that when an object gets squeezed, it becomes hotter. That's why we believe that the oceans are heated, because of this constant squeeze in and out action. Now we have all the answers for our investigation, but now we need to find life, isn't it? It turns out that we don't currently have the technology to drill 10 kilometers of ice about 620 million kilometers from Earth. What a surprise! And once again, curiosity is able to outsmart any of the problems we might find. We currently have a robot called Snotbot, which flies over whales when they snot with a petri dish, getting information about the whale's biology and health. This happens right here on Earth, but it can also be executed in Europa. The Europa Clipper Mission is set to fly over one of these geysers, which have been confirmed by the Hubble Space Telescope, getting information about what hides underneath Europa's surface. If you watched until the end, thank you, and consider liking and subscribing this video. Thank you so much, because these videos take so much time and effort to do. Until next time, see ya!